new lesson, and in this lesson we will explain deep first search with a matrix. In our previous lesson we explained how breadth first search work with matrix. Here we explain how deep first search or DFS works with adjacent matrix. Still, the concept is the same as previous example that we said deep first search, explore the graph as deep as possible, then start backtracking. So here, similar to the breadth first search that we explained on this example, DFS with matrix is like exactly the same as implementing with adjacent list. However, the only important thing that you should pay attention more is getting the neighboring nodes. When you represent a graph using a list, you already have the neighbor of every node inside the object as the value of the key node, so easily you can access that. For example, let me show you once again. Here, when you show a graph with a list, you have the neighbors of every node across them, and easily you can access them. But when it comes to matrix, with matrix, the most important thing is how to get the neighbors of every node that you are processing. Other things are the same, and right now I believe you already know how to work with DFS traversing and traversing a graph. So for example, if you consider this one and you start traversing this, for example, let's say you start traversing from this, the first thing that you need is you create a stack and you create a visited set in order to keep track of visited nodes and not repeatedly process them. For example, when you process this node here, and then you get its neighbors. Its neighbor is 5 and 2. So when you add 5 and 2 to the stack, and when you process them, and then suppose you come to node 5, 9, or 6, or 3. So again, for example, number 2 is checked here and checked here. So at this time, it should be added to the visited list, so that you should not visit this node again. Other than that, it is exactly the same process, and the process is already explained with BFS, breadth first search, also, like how you get the neighbors. You check your matrix and get the neighbors. Here the example is different, so do not focus on this example because this example is specifically ask a questions. I remember now that I had the first this question here, and then try to solve this question. For that reason, here are some more conditions based on the given questions. However, the general approach is already explained with breadth first search. Here, if you have some specific questions, you can add your questions in the comment, and I will go through your questions, and then we will explain them together. However, I will solve some general problems, maybe from LeetCode or HackerRank, relevant to graph and how to traverse the graph. So there you will see more details, and I will explain how each question is solved using breadth first search or deep first search, and how do we represent them, like do you represent using its adjacent list or matrix, all those details. However, until then, have a nice time, everyone.